Okay, so today we are going to talk about annuities. This is module 2 in our in this class. So I mean in D2L. So under annuities, we are going to learn about annuity immediate, annuity due, arithmetic progressive annuities, geometric progressive annuities, perpetuity. So many topics. And by the way, annuities is basically the foundation for most of other topics like loan payments and then bonds. So mastering annuities is very important for you to when you're continuing to the modules. So please spend a lot of time on annuities, especially do sample problems in D2L and sample problems in exam FM. You really have to master this topic in order to learn the other topics easily. Okay, so what is annuity? Annuity is simply a sequence of payments. Usually they are equal. Okay. And usually they are dispersed or received at equal interval of time. And this interval of time we call as payment intervals. And we need to define what are the rates we are going to use and whether the interest rate payments match with their payments. For example, let's say you're going to receive payments every 6 months. And if interest is compounding every 6 months, then they're going to match. If the interest compound every month, then they are not going to match. So that's another thing you need to consider when you are talking about annuities. So some examples of annuities: home mortgage, which is annuity. So we pay fixed amount equally dispersed over time, usually under some fixed rate. Sometimes you may have different floating rates, but usually mortgage are fixed rate. Then life insurance premium, again, you have fixed payment and then maybe fixed rates. And credit card debts, this can be non-level payments, but usually rates are fixed and then you pay it every month. And then installment payment automobiles, that's an example of annuity. Now these are from these things we can consider as annuity, but then there are products which have name as annuity, like life annuity. Okay. Or the product you will buy when you retire in order to have fixed income. So those are also other things we can consider as annuities. So in this slide, you will learn notations you will see in annuity chapter. First term, what's the term? The fixed period of time for which payments are made. Annuity certain, that means the payments are guaranteed to occur for fixed period of time. So those are called annuity certain. And this you can divide actually to three. Annuity immediate, annuity due, and then perpetuity. Now, if the payment is not guaranteed over a fixed period of time, then, for example, the life annuity, for this, there's no fixed period, only lifetime. Lifetime is random. I mean, we can say it's random. Then it is different from annuity certain. Okay, for example, pensions. Okay, so for example, let's say this one says it's going to give you a fixed payment for 30 years. Then the life annuity is payment as long as you live. So it's not fixed period of time. So this is different from annuity certain. Then the contingent annuity that are not certain are called contingent annuity. For example, pension is paid, so that's basically life annuity. And then there may be other examples like one person, as long as one person alive, you get payment, or as long as both alive, like maybe husband, wife, both alive, you get payment. So that kind of things, contingent annuities. Okay. The payment period, the interval between annuity payment is called payment period. Often just called period. Then we have two types of annuity right now. So this is come from actual annuity certain, annuity immediate, annuity due, and then actual three perpetuity. So the difference between annuity immediate and annuity due, when the payment are made. Annuity immediate payments at the end. Yeah, so it's kind of confusing. It's immediate, but the payments at the end. Due is at the beginning. Okay, that's the main difference between these two annuities. Then the perpetuity, again, you can define as perpetuity immediate and perpetuity due. But the key part of perpetuity is infinite number of payments. So there's no end to that. So the first topic we are going to discuss, annuity immediate. So remember, these are a fixed number of payments for fixed number of payments with the first payment at the end of the first time period. Okay, so if you go back here, the annuity under which payments are made at the end of each period for n period. So this is a number of payments are fixed. So basically, term is fixed. Then the first payment, that's the key to differentiate from between annuity immediate and annuity due. So the first payment at the end of the first payment period. Okay, so here you can see the first payment. These are the payments. So the first payment at the end of the first payment period. Okay, so what's the payment period? Here we define payment period. The interval between annuity payment is called payment period. Okay, so this is at the end of it. So when you have this kind of setup, you can ask two questions. One is, what's the present value? That when you are standing here and you want to know the present value. Okay, so basically you are calling it as discounting. The question is, yes, I'm going to get all these cash flows in future, but what is the today value or present value of these cash flows under given interest rate? The other one is future value. Okay, so if you come here, yes, I got all this payment last 10 years. What is today value, future value of these payments? Okay, today mean I'm considering from this point. Okay, time. Okay, so present value and future value. Now for annuities, if the payment amount is 1, okay, this is 1. Okay, so if it's not, if it is something else, then we have different notation. But if it is 1, the payment amount is 1, then the notation is present value is AN and I. So this is basically number of payments. And this is the rate we use. And this is for annuity immediate. And the future value use the notation SNI. Okay, so the notation, you need to really remember this notation because these are used in actuarial science all the time. So you have to be very familiar with this notation and know what they mean. Okay, so let's first calculate the present value. Here you can see this present value. The notation is ANI. And then what I can do, I can discount on the interest rate. So what's the discount rate we are going to use? We are going to use fixed rate. So V under compound rate is 1 plus I. This is called as discount factor from previous lesson. If you are not remember, go to module 1. We talk about discount factor. So what we do, we discount under we are trying to find present value. Okay, so for each $1 or 1 unit, we are trying to find the present value. So what I do, the first one, if I come here, I divide by 1 plus I. Okay. Then the next one, since I have 2 years, is 1 plus I square, or we call as V square, here V. Then the last one, it would be 1 over 1 plus I to the n, or I can notation wise Vn. Okay. So then when I sum up, I would get this statement. So I can take the common factor. Then this is arithmetic geometric progression. So if you have AR square all the way up to AR n minus 1, then the sum is what? A time 1 minus R over 1 minus R to the n, no? So we can, I mean, 1 minus R to the n or 1 minus R. So I can use that formula. And then here you can see, then once I apply that formula, I'll get this nice result. Then we already proved that 1 minus V equal D. I don't know whether you remember that. What's D? D and I, you can remember, is D equal 1 plus I. So how do I get that one? Remember that we had this formula 1 plus I times 1 minus D equal 1. Then from there you can solve for D and you get this formula. So then also you can see that 1 minus D equal 1 over 1 plus I, which is 1 over V. Okay, I mean V. So V equal 1 minus D. Okay, so I can replace V 1 minus V part by D. And then I get the second part. Then the D is actually I times V. You can prove that. So I would get this nice formula, which is 1 minus Vn over I. Okay. So percent value of n one unit cash flows is 1 minus Vn over I. Now this is annuity immediate, no? So you can see when it is I immediate, this is kind of like a trick to remember the formula, it's I. When we go to the due, you will see that it's the same type formula, but then I change to D. Okay, so it's just like to remember the formula. Okay, just a trick to remember. Okay, so next thing, okay, so we talk about present value. Now we can talk about the future value. So in order to get future value, I am standing here and I want to get the future value for this payment. So how do I do that? I would take 1 plus I and how many years? I have from n to 1, it's n minus 1. And this one is 1 plus I to the n minus 2. So I can add that. Okay. So basically, my expression would be future value. It's 1 unit, so I can use this notation. It is 1 plus I to the n minus 1 plus 1 plus I to the n minus 2 all the way up to last one, which is just 1. And then I can again use that geometric progression, geometric series sum. So when I do that, I would get what? 1 plus I to the n minus 1 over 1 plus I minus 1, which is going to be 1 plus I to the n minus 1 over I, which is this formula. Okay. Now the different approach would be you observe that this is 0, this is n. Here you have present value, which is an notation wise, and which we know that 1 minus Vn over I. Now I want to get the future value. The notation wise is Sni, and I want to know what. So we know under compound interest, this is compound interest rate model. So I know that compound interest future value equal present value time 1 plus I to the how many years. So this I have n year. So future value notation is Sni. Present value is Ani, 1 plus I to the n. Then I can substitute that formula we derived earlier. 1 minus Vn over I times 1 plus I to the n. When I multiply this, I would get what? I would get, so 1 times this, Vn times this, so 1 plus I to the n minus Vn time 1 plus I to the n over I. Now V time 1 plus I, what is V? V is 1 over 1 plus I. So from here you can see V time 1 plus I is 1. So Vn time 1 plus I to the n is still 1. 1 to the n if you want is 1. So this entire thing equal 1. So that would give us the same formula we derived earlier. Okay. So here, this formula, okay, that's the same thing we got here. Okay. So because of that, one can write, if you look at this, one can write Sni equal Ani times 1 plus I to the n, or the second way, Ani Sni divided by 1 plus I to the n. 1 over 1 plus I is V, so I can write Sni times V to the n. Okay, that's the formula here. Okay, so next type is annuity due. Again, I want to emphasize what's the difference. Annuity due mean basically the first payment at the beginning of the payment period. For example, mortgage or rent. You usually pay at the beginning before you occupy the premises. So it's different from annuity immediate where you pay at the end. Okay. So again, we can ask two questions. What is present value? What is future value? Now the notation look like same, but with two double dot on here, on top of A. And the same with future value. Notation look like same, but you have two double dot. Okay. That's double dot. So let's calculate the formula. You can see that if I want to get the present value, that's going to be what I have one here. Then the next one I have discount back to time 0. So V, and the next one again, V square all the way up to the last one, which is in here, which is V to the power n minus 1. So I can use the same approach. This one would give me 1 minus Vn over 1 minus V. 1 minus V equal D. So I write D. Now let's write the present value of annuity immediate. This is previous one is this is D, okay? So that formula is 1 minus Vn over I. So you can see the difference coming from these two terms. So the usual trick is remembering I is I, here D is D. So this is for due, this is for immediate. Okay. It just happened to be there, okay? So just you can remember the formula that way. So then we need to know the future value. Future value is basically, we can use the same approach we used last time, present value time 1 plus I to the n. Okay, you can do it another way. You can bring the percent. You can, for each cash flow, you can calculate the future value. Okay. So, but the second approach would be you just think like, okay, you have present value from this calculation, and after n years, what will be the future value? So I can substitute this formula, I mean, the present value formula. It's D, so this formula. Which should give me 1 plus I to the n minus 1 over D. Okay. So the formula wise, this one we write as Ni, but with double dot. Okay, so here you can find some relationship between annuity immediate and annuity formula. If you want to prove this, you can easily do that. You just take one side and then try to simplify and get the other side. For example, here, 1 plus I. What is AN? AN is 1 plus 1 minus Vn over I. So you will get 1 plus I over I time 1 minus Vn. So what is D? D is I over 1 plus I from module 1. So you can see this 1 over D. So this 1 over D time 1 minus Vn. So 1 minus Vn over D. But there's another name for this. This is annuity immediate, annuity D present value. Okay. So you prove this first statement. Okay. So the same way you can try to prove the others and see whether you can do it. Knowing these relationships sometimes useful when you are especially if you are doing some symbolic calculations. That would be very useful. Okay, so we talk about annuity immediate. We use the formula AN and SN, and then annuity DU double dot. So now the third type, perpetuity. The perpetuity, the key to differentiate it from others is payments are promised forever. So there's no end. So basically, you cannot calculate the future value at the end like this. So in here, we calculate the future value after n years. I mean, at the end of the term. Here, we calculate the future at the end of the term. We cannot do that, but we can calculate the present value. So the perpetuity, again, you have to type. You have immediate, that are basically payments made at the end of the time period, or due. The first payment made at the beginning of the time period. So for both, you can calculate the present value. Okay. So let me draw the perpetuity immediate. It would be look like this. So the first payment start from here, and then it goes to the infinity. Okay. So because of that, the notation for perpetuity immediate. So this is perpetuity immediate. The notation is this infinity symbol. So how you calculate the percentage? You take the discount value. So P time V plus P time V square. And so if you take the PV as common factor, 1 plus V plus to the end. And if you have a series going to infinity, you know how to calculate that. If you use the geometric progression, it's going to be 1 over 1 minus V. So PV, this is not present value, okay? This P time V. P is payment, okay? Payment size. This is payment size. V over 1 minus V. And this one you can prove that as I. Okay, so try to prove V over 1 minus V is I. What is V? V is 1 over 1 plus I. And then 1 minus V is 1 over 1 plus I. And when you simplify this, you can right away see it's 1 over I. I mean the V over 1 minus C. Okay, so that's the formula for annuity perpetuity immediate. The other one is perpetuity due. The difference is basically first payment start at beginning of time period. And it goes to infinity. Okay. So what you can do, you can again write the formula. This would be what? P plus PV plus PV square. The notation is a double dot with infinity here. So you can take P as common factor, 1 plus v plus v square. And then this one would be again 1 over 1 minus v. In the previous one, you had extra v here, but in here you don't have v, so it's just p. So then this is going to be 1 over 1 minus is d. Okay, so that's the actually I should have write p time here because this symbol stands for only 1 unit. In here I have write p time because this symbol stands for present value of 1 unit. This symbol stands for present value of 1 unit, paying forever. So you can again find the relationship between two, try to prove that, take one side and simplify and see whether you can get the other. Okay, so here some real life examples. Please go to this site and read about life annuity examples. Here 401k plan, which something you need to know. Okay, so the first example, calculate the present value and future value of annuity immediate of amount 100 paid annually for 5 years at the rate of interest of 9%. So we want to find the present and future value. Okay, so we want the present value, future value, annuity immediate, amount of 100 paid annually. So let me draw the timeline. Annuity immediate, so first payment at the end of the first time period, so 100. And the rate is 9%. So this is annual effective rate. Okay. Assume annual effective rate. So I is 9%. So now I can use the formula. So if I want to find the percent value for 1 unit, what's the formula? This is annuity immediate, so I will use the formula 9%. For 1 unit, it's going to be 1 minus v to the 5 over I. Okay, but since it's 100, percent value is going to be 100 times. Remember this symbol is for 1 unit. Okay, so I have $100 every end of every year. So 100 times 1 minus v over I. Later we will use calculator, but right now I want to use formula. So what is v? V is 1 over 1 plus I, which is 1.09 to the power negative 1. And what is I, which is 0.09. So you can substitute those values here. And see what you get. So let me use my calculator and find out the answer. 100 times 1 minus 1.09 to the power negative 5 divide by 0.09. So I would get 388.9651263. That's the present value. So future value, again for 1 unit it is S5, 9%, but it's 100 times. Okay, so every time I will get 100. So what I can do, I can use the formula 1 plus I to the 5 minus 1 over I, 1.0925 over 0.09. So when you simplify this, what do you get? I get 598.471061. By the way, when you're solving any problem, don't try to round it up right away because sometimes that would give you incorrect answer, especially if you are using that answer to do another second part 2 or part 3. Try to keep as many decimal places as you can until you reach to the end of the problem, and then that At that point, you can round it or round up. Okay, so let's go next problem. Suppose you want to buy a new car and your budget allowed to make monthly payment of 108. The car dealer asks down payment of 2000, which you already have in your saving account. Based on your credit history, you qualify for 60-month auto loan, which has APR of 4.18, convertible monthly. What is the price of most expensive car you can buy? So we need to know what would be the loan amount, present value of loan amount. Then we can add another $2,000, and that would be the expensive car you can buy. So the money we can spend on car is what? Down payment plus loan. So the down payment is 2000 and the loan, present value of loan. Okay, that's what we need to find. So this one says you can make monthly payment of 480. Okay, so here is times 0. And how many months? 60 months. So you have 1, all the way up to 60. So the rate is given as APR of 4.18. Now, what is APR? Annual percentage rate. This is a nominal rate, okay? If you remember from module 1, APR is nominal. There is a rate convertible 12 times per year. So this is basically, if I use mathematical notation, it's I12. Okay. So then what's the monthly effective rate? So nominal rate per year is 4.18. Then the effective rate per month, that's going to be I12 divided by 12, which is 4.18 divided by 12. Let me check the answer. So let's divide 4.18 by 12. I get 0.34833. This is percentage. Okay. So now I need to find the present value under that rate. Okay, so I have to find the present value. I'm standing here, times 0. Okay, so present value. So let's find the present value. So present value is, if it is just 1 year, it's going to be A60 under rate, which is 0.348333. But then this is not 1 year, it's $480. Okay, so that's one. Is it annuity DU or annuity immediate? So let's use annuity immediate. The big reason, usually we pay down payment right away, and then we start paying the rest once we buy the car. So I'm going to make this as annuity immediate. Okay. Okay, so let's apply the formula. For this one, it's what? 1 minus V60 over I. And what is V? V is 1 over 1 plus I. In this case, 1 over 1 plus 0.00348339. No? So then I can use this to find the answer. You just use calculator. So 1 minus S1 divided by 0.00 multiplied by 480. So I get 25,948.94583. Now that's the present value of loan, and I have to add another $2,000 because I have $2,000 in my saving account. So total, the value of the most expensive car would be 27,048.94583. So this point onward, I want to bring calculator to solve problems. So for these first two, we use calculator. After that, I want to use calculator. So the calculator we are going to use BA2 plus, or you can use professional calculator. This calculator you can use in your during the exam time, and it's very useful. So in next video, I will explain you how to use the calculator. Thank you. See you again in the next video.